Would you now please welcome Siemens Director of Business Development for Energy Services, John Saams.
Good afternoon. I like sort of the storytelling aspect that's been weaving its way through all the talks today, and I'm old enough to have stories, and luckily, at least I think I'm young enough to remember why I'm telling them. So what I'm here is to talk to you about net zero, and I put it in the context of energy, but really what we're talking about applies to water and waste as well. And one of the key things from the private industry side that we want to work with customers is we need to make certain decisions up front when we enter into a project or program. And the first thing that is very important if we're going to move towards net zero is establish what I call the end vision state. What does it look like? In a perfect world, where do we want to end up? And the importance of that is so that we don't make decisions that will become obstacles later. And the next topic, the decentralized or centralized heating or cooling plants, is a perfect example of that. Decentralizing, we can gain major efficiencies, but by decentralizing, we may cut off the opportunity to do renewable solutions, especially in thermal, depending on what your systems are like. And then that leads to the question of what is net zero, and what does that include? And I can't believe I used a minute up already. So usually in net zero, we want to start with our demand side and then move to our supply side. For energy conservation measures, we want to characterize how cost effective they're going to be. Normally that's in payback, simple payback. And the percent of the overall savings is going to be small. So we want to then compare that to our renewable performance. And renewable is not a fixed cost. The larger the system, typically the more cost effective it's going to be. So as the system grows to meet more of your demand, the cost per unit is going to decrease. And then that creates a decision line, which was shown up there as a fuzzy line but didn't come across, to show where the two intersect. And it's a fuzzy line because we don't want to make decisions strictly on forecasted numbers. We want some management process in those decisions. So on the demand side, you may use a different resource than you are on your renewable side, and you need to make sure that those two different resources coordinate and they understand each other. So if you have a consultant, they need to be working with your supplier. Looking specifically at different renewables, this is, the yellow is electric, red is thermal. And you look at different options and what they can both meet in your total demand. So the ones over on the left meet less of your demand. The ones over on the right can meet a lot of your demand. And you compare them. This is notional, so the numbers aren't necessarily factual, but it gives you an idea of, is it better to build one large solution? If you have centralized steam cooling, that might be an option. Or if you don't have that centralized system in a campus setting, what can you do on the smaller scale side, which is over on the left? And then those mix and match. And again, the size matters. So if you do a lot of small systems that detract from your larger system, you may make that large system less cost effective, which goes back to my first thing. Let's have an end state in mind of what we're working to. Companies, we often look at things in a campus setting, but this also can be taken down to a building setting. And we play in a lot of different roles in that net zero goal, as do many other companies. So the key is finding the companies that have the strengths that you need. In the federal sector right now, we're getting into much larger projects, diving deeper, and we are still treating them as projects and individual companies. I think both what the federal government and the private sector need to do is we're good at creating collaborations between the government and a company. I think the next step to get us to these deeper savings is let's have a collaboration between the government and multiple companies working together to deliver the best value to the government. We've done that in the defense industry, where they partner up for specific procurements. We need to start thinking that way in net zero. Certain companies have strengths, and we need to play that across the board in that overall strategy. The value of a net zero, everybody talks about the cost and having them cash flow and the life cycle cost analysis, but there's other benefits, and I think we all here understand specifically emissions, we'll either eliminate or at least have a much shorter carbon cycle on our solution if it's renewable. Energy security, net zero sort of implies that, but before you play this, make sure that your solution is actually delivering energy security for the mission. A PV system for a mission that has to run all night without storage it might be part of that security solution, but it's not the entire answer. And then increasing the strategic value of a site, building, or campus. And then revenue sharing, going back to demand side versus supply side. If you have a source of revenue for a renewable system, don't defer it. Take advantage of that because it exists now. The production tax credit is a perfect example of that. And then continual improvement. The last thing on the first slide I didn't hit was treat this as a program, not as a project. ISO 50001 is on the streets now. We need to start adopting that, and let's move forward in a programmatic, disciplined manner to reach net zero. Thank you.